This is question number 36 from the August 2017 Algebra 2 exam. Long story short, the first part of this problem, we're basically trying to find the exponential regression equation from the data in this table. So we're going to be using a graphing calculator to help you do that. The first thing you want to do is press the Stat button and go to Edit. From there, you'll have the table of values. It'd be labeled as L1 and L2, and you'll input all this data. With that done, you're going to press the Stat button again, go sideways to Calc, and choose the exponential regression, which is exp reg, and then just press Enter. And what you'll get displayed is an A value, rounding to the nearest thousands as they want, to be 4.168, and a B value of 3.981. Now, of course, this is in the format of an exponential equation, so that's y equals a times b to the power of x. So the actual equation that we want to write down will be y equals 4.168 multiplied by 3.981 to the power of x, just like that. Now, for part 2 of the question, it says that we want to know, okay, so people are likely to suffer from foodborne illness if the number of spores exceeds 100, the number of spores being our y variable. So what we're going to do is we're going to replace the y variable in the equation we just figured out with that number, 100. And by doing that and solving for x, we would be able to figure out the maximum amount of time that the meat can be kept at room temperature. So you can see on the right-hand side, I've gone ahead and done that. Now, because we're solving for an exponent here, we're going to be using some logarithms to help us out. But before that, we can actually simplify this equation a little bit by dividing both sides by 4.168. And that'll just make things a little bit easier for us to work with. So it's going to make those cancel out. And on the left-hand side, that would become, if we divide those, 23.99 if we're rounding. And on the right-hand side, we're left with 3.981 to the power of x. Now at this point, we're going to use a cool little trick here. What we're going to do is take the log of both sides of the equation. So log of 23.99 is going to equal log of 3.981 to the power of x. Now, why did we do that? Well, there is a logarithmic law where we can take the exponent, this x here, and bring it to the front. And it's still the same value. It's not changing it. So we can rewrite this so that the log of 23.99 is equal to x log multiplied by the log of 3.981. Well, now at this point, it's quite easy to solve for x. All we need to do is divide this whole thing by log of 3.981, causing it to completely cancel out. And then on the left-hand side, we'll do the same thing. We'll divide by log of 3.981. And now we've isolated x. So x is going to equal log of 23.99 divided by log of 3.981, which is 2.3. Now be careful though, you might think, oh, we're done and that's the answer. But remember, we need to give the maximum amount of time to the nearest quarter hour where y is equal to 100. So the nearest quarter hour would actually be 2.25. I mean, you'd have to round down to 2.25 or round up to 2.5 to get to the nearest quarter hour. And obviously 2.25 is closer to 2.3 than 2.5. So that is the maximum amount of time. I guess if we're going to include units, we would say 2.25 hours. All right, hope that was helpful, and that is it for this video. Thanks for visiting JD's Regents Preparation.